Let's put on some music. Hello Earth. Welcome to the very first episode of Making Cell. My name is Federico Pereiro. Thank you for coming and watching this video. So the idea of Making Cell is to create a series of videos where I'm going to record myself creating a new programming language and environment called Cell, which, by the way, you're looking at it here. It's open source. It's already on my GitHub. So this is definitely the first link that I'm going to post. So there's two things that are a bit interesting about this, I think, or weird. The first one is the fact that I am streaming or filming myself while building a programming language and environment pretty much from scratch, almost from scratch, let's say, because normally people just work by themselves for a long time in it, perhaps get some feedback from different online communities, and then finally one day they release the first version of their programming language in a website. But I'm not going to do it like that. I'm going to build it from scratch, filming myself, and hopefully some people find that process interesting, and also perhaps allows me to create an audience and a community of early users. I've done a lot of programming, open source programming, let's say much more in isolation, and I'm ready to try something different. So here we are. Then the second interesting thing about what I'm doing, or weird, is that I'm building an entire programming language and environment from scratch. Not really only that, it's really a programming language, a database, a service, and an interface maker, let's say. So I know enough programming because, that to realize that this is batshit crazy. At the same time, I'm pretty confident in the approach, so I'm willing to give it a try. For 15 years, I wanted to do this since I started programming, and here we are. So I said that we're going to start from scratch, but I'm kind of cheating a bit because over the last 3 months or so, I wrote this thing called the Organization of Digital Information Systems, which is, by the way, also making the note to paste the link afterwards. It's too short to be a book, too long to be an article, about 50 pages perhaps. You can see there's a lot of scrolling you could do here. So this is definitely a wall of text, but this is going to be the spine of the entire programming language and environment. So just wait a sec. Yes, we're still recording. I'm still quite new to this whole recording thing. But anyway, so if we are looking at this, and this is the spine of Cell, it will tell you what this is about. So let's just go to the main point of the entire treatise so you can get a feel for what I'm trying to build and see if it's interesting for you to watch or not. So here's the main thesis, the main point of the whole thing, which is to organize any system, any software system, any digital information system, always focus on the data. What I'm saying is that the way to design proper digital information systems, software systems, is to focus on the data that they communicate, transform, and store. It is as simple as that. Now, simple is not easy, but still, simple is what we're aiming for. So what I'm saying is, like, look at the data instead of looking at everything else. And what this is everything else that we're normally looking at when we're building software. We're quite obsessed about programming languages, programming paradigms, type systems, libraries, all of this, and AI. I'm recording this at the beginning of 2025, and let's just say that AI is definitely a topic of interest, to say the least. But still, I still believe that to create systems elegantly and efficiently, the way to do it is to focus on the data that the system holds and the data that the system transforms and communicates. That's it. The way I see it is like when you're building a software system, really think of yourself as a painter. What you're doing is you're creating a painting, hopefully a beautiful painting, or at least a somewhat beautiful painting. And what I'm saying is that the data is the painting itself. That's what you're really creating when you're a maker of software. But what I notice is that we as painters, as software developers, we're not really looking at the painting. We are obsessed with the brush, and we're obsessed with our palette. Anything but the painting. So it's almost like we're doing the painting, but we're not looking at it while we do it. So The entire idea of Cell is to create a language and environment that is going to let us look at the painting and work on it much more directly. It's going to be different, so let's give it a shot. So we're not really starting completely from scratch, because we have about these 50 pages of document that give us some pointers of what to do. It gives us the main thesis, which is focused on the data. And after this, we have the 5 pillars of the approach. That Cell is basically going to be the incarnation in code of these 5 pillars, which is, we have a single representation of data, which is one way to represent structured data with text. Then we have single data space, which is the idea that rather than having snippets of code or data here and there, like just send a request in Postman, you get something back, you store it in a file, or you have a database dump somewhere, or the actual live database. That is, you try to organize that whole thing into one space where every part of the data has an address or a path to it. So that's the second pillar. The third pillar is call and response, which is how you can actually use data to represent a change in data. Because you might readily believe, oh yeah, sure, you can find a decent representation of data that more or less works for all of our use cases, although that's quite a bit of an ask for some programmers. We'll get to it in a minute, by the way. But I'm really trying to find a way to express change in data, like the dynamic aspect of data, with data itself. And the idea is that if everything is data and change is representable with data, we never have to leave data, so to speak. We can always be in the same area. The system is self-similar, and that's a term that I'm going to be using a lot. Self-similarity. And there's, I think, very good reasons for using self-similarity. Living things, living beings use a lot of self-similarity, and you definitely also find it in nature, in physical structures. For example, snowflakes are made of fractals, which are self-similar. Snowflakes. So I'm going to be making a few notes, and I'm going to put them in perhaps in the description of the video. Why not? So they can be accessible there. So these are the first 3 pillars. I think there's no point in covering more. So we can just at least start to look at how the data would look, right? Because if everything is data and we are focusing on this painting, which is the data and how it changes, how does this data look like? So that brings me to pillar 1, which is the single representation of data. So when I was coming up with this, I was realizing that we have all sorts of formats for data. We have, well, programming languages. If you see programming languages as data, not programming languages, the programs themselves as data. Each programming language has its own syntax. So rules on how you represent that data using text. You also have data exchange formats. 2 of the most known are XML and JSON. And I used a lot of JSON, a bit of XML, and oh, great song, by the way. So, and I'm not really satisfied with them. They're just difficult for humans to read, and also leave space for ambiguity in terms of the space. So, for example, let's just give you this example. Let's say you have this in JSON, which is an object with one key foo that maps to a value bar. You could write it like this, but you could also write it like this. These are equivalent, but they don't look the same. And I started to get tired of this level of freedom or ambiguity. So I wanted something more structured than that. Also, even after 15 years of programming, I realized that having curly brackets or square brackets for lists, arrays, or having the commas between the items, having to put the quotes in front of every single text, it really adds a lot of burden to your eyes, and it's not particularly necessary. So I basically came up with a concept that I call this within pillar 1, single representation of data. We're just going to use text to represent data. Let's say all data for now. And then we are going to use just 4 types of data: number, text, list, and hash. So number and text, I think you can understand them without much more explanation. A number is a number and text is text, but the interesting thing is a number is made of digits. Also you can use a dot or a minus in front, but that's pretty much it. And text can be just any characters that are not considered to be a number. So this is a bit of a vague definition. We'll make it tighter later, but this is enough to keep on going. The thing is, you don't only need these, which are called single types, I remember, or simple types. No, single types. We also have multiple types, which is basically a bag of further values. So there's going to be 2. If you have 2 single types, you're going to have 2 multiple types. Think of them as bags, so to speak, or shelves with specific locations. So the first type of bag is a list. In a list, the keys which let you find the value are numbers. So you can see that 1, 2, 3, those are the keys. For those that are not doing much programming yet, think of keys as imagine you have a wall of lockers, and each locker has a number in front of it or an identifier. So in the case of a list, every key would be the number that is on the door of the locker. And then so you go to locker number 1, it's the one with the 1. So then you go and open it, and inside you find eggs. And if you go to locker number 2, where the number 2 is written on the door of the locker, you just go, and when you open it you find butter. So that's essentially how a bag, or specifically a list, works. And the second multiple data type, I call it the hash. Normally it's called an object or a dictionary, but I was really tired of those terms, and I decided, whatever, we're just committing a lot of heresies by just trying to reinvent the wheel in a different way. We're just going to use a new word, which is, by the way, not super new, but it's less common to call it a hash. So I'm calling it a hash. And a hash, the door of the locker doesn't have a number in front, it has text. So you can see there's a nice symmetry here, because you have 2 single types, number and text, and 2 multiple data types, list and hash. And in the lists, you have the first single data type as key, and in the hash, you have the second data type as key, which is the text. So in this case, you don't care about the order of things. What you care is that, let's say, the locker names maybe tell you more about what you want. They give you more context, more information. So when were you born, the first name and the last name. So you don't have to remember that, oh, in the first locker I put the date of birth, in the second one I put the first name, in the third one I put the last name. No, it's just I just call it like it is. So this is a hash, really. And you can start to combine things, right? So for example, you can look at it here, and you will also notice how white space or empty space actually starts to take an important role in this. That's here you have a list with 2 elements, 1 and 2. What's inside each of them? You have 2 hashes. A hash in number 1, year born 1959, Gustavo Cerati, an amazing musician. We will listen to him maybe in a following episode for sure. And then we have in the second hash, the second element of the list is a hash that belongs to John Squire, another great musician, by the way. And yeah, so you can see how we combine them. And how do you know where one ends and the second one begins? Because we're using white space. This one here, all the space below it, the white space, is kind of telling you, and hopefully this is noticeable, and if it's not, just let me know. Maybe I can come up with a better way of explaining it. This one clearly marks the boundaries of all of this, of the first hash. And same goes with the 2. So you notice that every line ends with a value, like, for example, 1959, Gustavo, Cerati, 1962, John, Squire. So you might not be, especially if you're a programmer, you might not be very impressed with this, but let's just look at this for data and then how you would write this with JSON. With JSON, if you wanted to use space, you would have to do something like this. Gustavo. I'm not typing very quickly tonight. I will get there. So 1962 Squire. So notice how much more noise there is. We have these square brackets, we have these curly brackets, we have this comma, we have all of these quotes around these guys here, these texts. By the way, programmers normally call text values as strings. I'm not going to do that at all. I don't see any reason for doing that. Let's just call it text. It's easier. Number, text, list, hash. End of story. There's a lot of what I do that is, I think, relatively novel or perhaps interesting, at least to me, is that I'm not afraid to rename things if I feel that the existing names are not really clear or associative. I'm just willing to be different and and get people mad or just to say what the hell is that, because I think proper naming is really important. In that sense, I'm quite Confucian. So we have let's look at the amount of noise we have here. All the quotes, the colons here, that's completely missing from here, but the amount of information here is the same. And you could say, hey, you're cheating, this is actually not an efficient way to represent the JSON, you could just do it like this. Yeah, sure, I can do it like this. But still, I missed this. This to me is way more noisy than the other one. This is cleaner. And basic as it sounds, this type of thing, I feel makes a huge difference for your ergonomics, for anyone's ergonomics. When you're looking at data all day long, it's just much nicer to see it in the most unobstructed and clear way. So I'm just going to go with this notation, and we're going to use it for everything. All the data that is in our system, the data that flows through our system, and the code itself is going to be written like this. We will add interfaces later that might, let's say, make a couple of simplifications to this structure, but the entire system is going to be based in this. So this is the first way towards looking at the painting. And the other thing besides the cluttering, I think that this represents, and by the way, this is JSON, which is good. If we did this with XML, it would look even worse, believe me. So once things are more decluttered, what I want to do is, where was I? Sorry, I just lost my train of thought. Oh yeah, sorry. The fact that this is, I cannot do this like born 1959 and just put commas and do this, or just create a space here. I cannot do any of this. This way of representing this list of 2 elements with 2 hashes inside with this data, there's only one way to write it. You cannot switch it around. So there's only one way to represent this data, that is right here, and it's like this. So 2 programmers, or a programmer and a machine that are, let's say, emitting the same data, are going to emit the same sequence of text. So a lot of, let's say, unnecessary differences are going to be removed. For example, hashes, the keys of hashes are sorted alphabetically. So BFL. So I cannot write it like this. And if I do, the system is going to change it. It's like, no, first name goes here. That's on purpose, so that when you're looking at something that represents A, it looks like A. There's no difference. So anyway, that's the basis with fourdata. And we actually, I think, can skip pillar 2 for now and just go to pillar 3 for a second, because I want you to take a look at how a data transformation happens, right? Because if our system just consisted of data and that data didn't change, there will be no system, there will be just data. But when the data becomes dynamic, when there's data that transforms other data, and that basically is software, it's data that transforms other data, things get interesting. So I came up with this notation, and I think this is a good example, the plus. So imagine that you want to sum. In a normal programming language, you would say something like 10 plus 10, right? Also when you're doing math. So now just bring this to fourdata, which is this type of notation. So instead of doing it like this, what I'm thinking of is that there's going to be an area of the data space, that's pillar 2, that it could be a function that basically sums things. So I'm just going to call that with a plus. But the thing is, I need to call the plus. I want to say, hey, I want to go to that plus and send it a message. So I'm going to make a call to plus, and I'm just going to pass it one message. So what message do I want to pass it? Hey, I want to sum 10 and 10. So I'm just going to pass it a list with 2 elements. The first one is a 10. The second one is a 10. Note that we are completely staying within the bounds of fourdata here, right? Add is a key to a hash. Plus is also a key to a hash, and then we have a list here with 2 elements, both of them numbers. So we're still here. We haven't added any syntax. And then, if the plus function is really what we think it is, we're going to obtain a result, which we put after the equal, and that gives us 20. So this is essentially how you represent change. You represent transformation in fourdata. Sorry, not in fourdata, in Cell, but you use fourdata for it. So that's essentially where we are headed. So I think it's time to set some, let's say, besides this treatise, which we're always going to have open, and we actually might find things to fix later as we go into the practical depths of implementing Cell. I think we are ready to try to start coding something, right? I have about 15 more minutes. So where can we start? I think that probably we're not going to code much, but at least we can start thinking together, what should I code next? By the way, I have some code already here, cell.js and on list.js. I'll get to that later, but I don't want to look at this one right now. I actually will try to start really from scratch. And actually, to prove it to you, I'm just going to move this to old cell, so I just can completely ignore it. Good, and we can start from scratch. So this is a major decision I'm making right now. Well, I had it in my mind before, but we're going to make it together now, which is the following, which is the web browser is our home, our base. So we're always going to start from a web browser, because pretty much everyone, on every device that they own, every human, they always have a web browser available. And a web browser is immensely powerful. It has a quite fast programming language underlying it called JavaScript, in case you didn't hear of it. And it also has a way to build user interfaces, which is the DOM. So we can do a lot on this portable, let's say, fast runtime and interface maker. And by the way, it's an open standard. The web is an open standard, and that should not be discounted. So it's not controlled by any company or group or government. And it's been around for 30 years already. So this is going to be our bet. We're going to bet on the web browser as the basis of Cell. We will also have to create some sort of server runtime as well for Cell, but we start on the browser, and it should always be browser first. Note that I didn't say mobile first, because it shouldn't matter if you open your web browser in a phone or in a computer. It should not matter. So if the web browser is home, we need to figure out a way to get some of Cell running in a web browser, which is going to be interesting, because besides this 50-page thingy, I have nothing. So how do we go around this? So we have to build really 4 things. I think I will explain in the next episode why it is 4 things. For now, suffice it to say that it needs to exist as a whole, Cell. So I will definitely rely on existing technology like the web browser. I will also use some databases and server runtimes, and if you don't know what a server runtime is, don't worry, we'll get to that later. But it has to be coherent. Therefore, I need to build at least Cell versions for each of these things. So, I mean, a way to do it in typical waterfall fashion would be, okay, first we build the programming language completely, then we build the database, then we build the service, then we build the interface. But no, that's not the way we should do it. The way we should do it is, as much as possible, we should do this in parallel, a little bit at a time. So build a bit of the programming language, enough that, let's say, we can already start supporting the notion of a database, although it might not be a proper relational database in a hard drive in a server, but still something that allows you to structure and query information, which in the end is really what you want out of the database. Well, that plus durability, right? I might have to change this, but what I'm getting at with database here is, like, I want to structure and query information or data, and same with the service and the interface. So we need to start building a little at a time in parallel, which is going to be tricky. But I think we can start, and we'll start by just opening a page. So I'm going to open my local. What's the path to this? Typos. So we have this. We have an empty web page here. So we're just going to open this empty web page, which is cell.html, and then we can try to put something there so you will just see it. At least we know we're in the right place. All right, hello. Okay, so at least we're looking at the right thing. So the idea is that, let's say, for the first few sessions, all our progress is going to be in a way that if you open this web page and the JavaScript behind it, we'll start saying something. So I'm going to be working on this thing, and for now as well, and for a while, I'm going to be working on my text editor, which is NeoVim, and from here I will just be making the code changes. Eventually, I dream of having the editor for Cell inside Cell itself. So eventually I won't have to ever leave the web browser. I will stay in the web browser all day, but that will only happen when I have enough of the niceties of this amazing web editor, which is based on Vim, which in turn is based on Vi or V. And when I have enough of that, then we will move here. And the fun part is that, hey, if I make it that long, then you'll get to watch it if you want. We'll record that too. For now, we have we are going to create a new file called cell.js, momentous thing. So I am going to, I won't say cheat a bit, but I need to rely on some prior art here to at least allow us to do some things on views for now. So that's why I included this library called gotoB, which is open source, by the way. It's here. And it's just going to make our life easier, at least in the beginning, let's say. So this is essentially an entire front-end framework. It fits in one file. It's about 13 kilobytes or 14 kilobytes. And honestly, in projects where I just work by myself, I prefer to use this than to use React, Vue, Solid, anything else. It just it works very well for me, and we're just going to use this to get some things going in Cell a bit quicker. Then we will see whether we really need it. Perhaps at some point we really don't need it and we can just drop it completely. So let's go back a bit to the design board. So we want to make a programming language to implement it, the runtime completely. So we're going to be relying on a few things. Relying on JavaScript and also gotoB, which is this library. And we're going to rely on the DOM and the web browser in general. So I think if we go to the original document, the Organization of Digital Information Systems, if we again go at and look at the main point, it's like it all starts with the data, looking at the data and always coming back to the data. I guess the very first thing we can do is just have a nice big Textarea, which is an editable element, and just be able to see some data there and perhaps even modify it. So I think that might be a good target to just go for. And not only that, so let's just list our first requirements for the first version of Cell. And we're going to iterate. Requirements for the very first thing, for the first version. We want the text area. We want to, what do we want to do? We want to see for data, of course in fourdata format. And actually see data is a bit insufficient, because what we want to do is we need to get data in there and just get it out. So getting it out, it can be as simple as just selecting the data and just copying it, right? We all have that capability, at least in a computer, I think also in a phone. But we might want to transform JSON data into fourdata, because JSON is still used everywhere as a data format. So we might want to do some transformations there. So read from JSON. We could also perhaps output to JSON. And that's going to be our starting point to create this chalkboard, so to speak, where we can just start at least seeing some data, and from there slowly, organically start creating the system. So I think I'm going to stop here, and we'll continue tomorrow. I plan to do this 3 to 5 times a week, and just see how far we can get. So thank you so much for tuning in, and I'll see you next time. Thank you.